Today we discuss how can you convert a Fredholm integral equation problem into a boundary differential problem. That means we are encouraged to find a differential equation with boundary differential problem. Here we consider a particular case yx is equal to x plus integration 0 to 1 kxt into yt dt. Here this k is called the kernel and k is equal to t into 1 minus t if t is less equal to x and kxt is equal to x into 1 minus t if t is more than x. Now the given integral equation we should need here this integral equation cannot be differentiated directly, so we need to simplify. So how can we simplify? We write yx is equal to x plus 0 to x t into 1 minus t yt dt plus x to 1 x into 1 minus t yt dt. Now it is not our well-known form, so we need to write in our well-known form. So this can be written again: x is equal to 0 to x t into 1 minus t yt dt plus we write it 0 to 1 and just subtract 0 to x. So first of all we consider the minus sign 0 to x into 1 minus t yt dt plus 0 to 1 x into 1 minus t yt dt. This is equal to x to x. So after simplification we can write it 0 to x minus t into 1 minus t yt dt. This is plus 0 to 1 x. Since x is treated as constant, since the integrator is p, so we can take outside of integration. We can take x outside of integration and we get 1 minus t yt dt. Now it is our well-known form, and taking the derivative we get, that is differentiating with respect to x we get y dash x is equal to 1 plus taking the derivative of this function will be 1 minus x. Just we need to replace t by x minus sorry no, don't take the derivative. We should need to take the derivative of this function. So this is ultimately plus minus 0 to x 1 minus t yt dt plus here this part is a constant and it is x. So we get only 0 to 1 minus t yt dt. So this is our well-known form, and now again we differentiating this function with respect to x we get y double dash x is equal to the derivative of 1 is equal to 0 and the derivative of this function will be minus 1 minus x yx, and it is also 0. It's this constant, so its derivative will be 0 plus 0. So or yx plus 1 minus x yx is equal to 0. This is our desired differential equation. Now we need to choose the boundary conditions. The boundary conditions are obtained from yx and y dash x. Since the boundary conditions means here the conditions should be given at 0 or 1, and we need to put the value at yx, y or y dash x. So if that is y0, y1, y dash 0, y dash 1, you should need to put either y0 y1 or y0 y dash 1, either y0 dash y dash 0 and y1 or y dash 0 y1. That is, you need to consider this value, these two values, or these two value, or these two value, or this value. If you choose y0 and y dash 0, then it will be initial value problem. So we need to find out a boundary value problem. So of course you have to find this set. Now we observe that y0. If we interested to find the y0 means this value is 0 and this value is 0. So of course the conditions, boundary conditions, the boundary conditions are y0. Here y0 is equal to, this is 0, its value is 0 to 0, its indication of course 0, and it is 0 into something, some constant, so 0. So this is equal to 0. And another one, y dash 0, if you find the y dash 0, then it is not considerable. So we need to find out y dash 1. Y dash 1 means 1, and it is 0 to 1. 1 minus this function, and 0 to 1, so it is negative, it is positive. So y dash and y dash to 1 is equal to 1. So we have already finished.